In this video, we're going to try and prove the same side interior angles theorem. So if you look at the picture, 4 and 5 are same side interior angles. We're trying to prove that they are supplementary. We could do the same thing with angles 3 and 6. For this particular proof, the only thing that we're allowed to use is alternate interior angles theorem. Technically, at this point, we could use corresponding angles postulate because we've proven that we're assuming that. But for this particular proof, I'm asking you only to use alternate interior angles theorem. So what does that tell us? That tells us that alternate interior angles are congruent. We proved that earlier. So we need to start making, again, a game plan for this. You can pick either 4 or 5 because that's what we're dealing with in the proof, right? We're talking about 4 and 5 right here, okay? But pick one of them and try to make a connection with alternate interior angles. I'm going to pick angle 4. So if I'm looking at angle 4, angle 6 is alternate interior. So let me get my pen back there. Okay, what I know then is that this angle and this angle have to be congruent. That's one thing that I could say. And then, typically for proving these sorts of things, now try to connect angle 6 with angle 5, the other angle that we're trying to talk about in the proof statement. And so what do I know here? I know that this angle and this angle put together, they add up to 180. They're supplementary because they form a linear pair. So let's just kind of write that down and see what that leads us to think. You might already have an idea. Maybe I should mention the idea because we talked about a game plan here. If 5 and 6 are supplementary, and I know that 4 and 6 are the same, I want to be able to plug a 4 in place of the 6 and basically think of the idea of substitution. We can't use that rule. We'll talk about that in a little bit. So let's write out our proof here. First thing is we write down the given. So L is parallel to M, and that was the given. Okay, step 2. Again, there's a couple ways that you could write this out because we know we're talking about alternate interior angles theorem. I'll just start with that. Angle 4 is going to be congruent to angle 6 because of alternate interior angles. And we also mentioned how angle 5 and angle 6 are supplementary. Okay, they form a linear pair, so that's going to be the linear pairs postulate. Okay, what I want to do is be able to say, well, I know 4 and 6 are the same, so why can't I just put a 4 in place of that 6 and write that as my next statement? I think logically that makes sense to us. Okay, that we can kind of substitute that in. Okay, but just like some of the previous videos, we don't have a substitution property of congruence. And unlike some of the other videos, these are not saying that there's a list of angles that are all the same as one another. Okay, we have this idea of supplementary angles mixed in here. So anytime you see this, if you go and look at what we call the congruent supplements theorem, okay, that is the connection that says, in this case, if I know that 2 angles are supplementary and one of those angles is congruent to a third angle, then we can do the substitution property. So you need to really go look at what that statement says. You need to go look at our previous note sheet and look at some of the pictures. But that's the reasoning we would use to make that last step. Using steps 2 and 3, the congruent supplements theorem is what says I can now say step 4. So I'm going to stop right there. And if you have questions, make sure you ask at some point.